Anytime an astronaut goes into space, he or she takes tools along. But working in little or no gravity, or microgravity, can make things tough. So you need specialized tools to do the job. Engineers at NASA have challenged college students to help them design the next generation of tools. The microgravity team at Boise State University has a specific assignment.
In the future, NASA hopes to intercept an asteroid and do experiments on it. And so this tool is one tool that they hope will be able to be used to collect rocks off of it.
So our tool is a grabber. It's a float sample grabber. It picks up loose rocks off an asteroid surface.
And picking up rocks in space isn't easy.
Here on Earth, we have gravity that we consider normal, and we can pick things up easily. So on an asteroid, there's very little gravity. So if you were to just reach out and try to grab, they're called float samples, which is basically a small rock on the surface of the asteroid, you could knock it or yourself out into space.
So NASA gave the BSU team the parameters for the tool. That means the general size and shape and what the tool should do. And then the students started brainstorming. And where do you think they got the inspiration for their tool?
We saw basically a dog scooper, that you have in the park, and we said that's a great idea.
So the team went to work. Everything had to be designed from scratch, with everything, and I mean everything, even the tiniest screw had to be approved.
There's a big handle. It has to fit those gloves of the astronauts. They're really bulky. It's like a hockey glove. And the next thing you'll see is there is a set of 3 boxes on a pulley system on a conveyor belt, and there's a very clear handle that you're supposed to grab, and that's how you advance the boxes. And when you squeeze the trigger, the boxes will open.
The biggest obstacle, I think, is just trying to get all of the pieces parts to work exactly the way we intend. We spent a very long time working out lots of little kinks as we found them in the design.
And then the big moment. NASA divers try BSU's tool in NASA's Neutral Buoyancy Lab at the Johnson Space Center in Houston. Their NASA engineers put the tool through a series of tests to see if it could someday be used on an asteroid. So Camille, what happened?
We went to NASA Johnson Space Center and visited the Neutral Buoyancy Lab, which is the big pool where they allowed us to do testing on our tool and figure out how well it worked. What we did was we took a tool that we built and we got to sample those products. Basically they were test rocks that were sitting in the bottom of the pool. The divers went down and they operated our tool with their hands, and they opened and closed the tool and was able to collect samples off the bottom of the pool.
Did it work?
Yeah, it worked really well. It was one of the fastest tool there at that week, and we were able to collect a bunch of different samples as well as test the different ways you can collect a sample. So sometimes they would throw the rock across the tool and try to grab it while it was moving across space. And they would also do tests with, can they use it with their non-dominant hand? Will it work well with either hand? And it worked pretty well. The divers were pretty happy about it, and they came up and gave us some really cool tips for the future.
Would you do it again?
I would definitely suggest anyone interested in a lot of space science research and getting a hand on what you can do as a NASA scientist to definitely join the program. I know that I am definitely geared up to participate in more NASA projects that will help broaden my skill set and give me more exposure to what it's like to be a NASA scientist or engineer.